Hello and warm welcome to everybody. Welcome to this webinar conducted by GPBM Industry. Just making sure a few things here before we get in. I hope everyone can hear me. Yeah, all right. Yes, so we can start now with this presentation. So welcome. Today's agenda is we'll be talking a bit about GPBM Industry, and then we'll have the presentation, which is the main topic for the webinar, how to choose the right battery for your application. And then we'll have a 20-minute Q&A. This section will be recorded, I believe, and then it will be available later after the webinar as well. For the Q&A session, we request you to type in your questions anytime you like in the chat function here, and we will take it up during the Q&A session. But yeah, hopefully we go smooth till there. So to start with what we are, a small introduction. And also to introduce ourselves, of course. My name is Siddharth, so I'm taking the first half of this presentation, and I'm a product manager at GPBM Industry. And the second half of the presentation will be taken by Luca, who's a sales manager in Italy, and is also a rechargeable enthusiast. We'll be taking you through the presentation, and also for the Q&A, we'll be joined by Mr. Anas, who is sales manager of France, and will be able to answer your questions during the Q&A session. All right, so just a bit about GPBM Industry. So we are a division inside GPBM Nordic Group. GPBM Nordic as a company was formed in 1986, and we were a battery supplier under the name of Sebon. And in '98, we became GPBM Nordic. And then in 2006, we became a Nordic group consisting of companies in France, which is GPBM France, and Italy as well. And then all of the Nordic countries. So we are pretty much pan-European. We have offices in all of these locations I mentioned, and also partners in the UK, in Spain, in Germany, who we work with for our customer projects. So what are we? We design, manufacture, test, and deliver standard and customized battery solutions. So this is what we do in our division. We have other two divisions in the group, which is focused on safety products and also on consumer products, energy products. So as I mentioned, we have offices in 7 countries and also in Hong Kong as well. Our services, just to briefly tell you what we do. We have a broad assortment. We work with different suppliers of different technologies of batteries, and in order to fulfill any kind of requirements from our customer side. We have a production at Europe. So we have a sister company in the group called Exo Industry, who we work with for particular, who has a production line, and we are able to produce in Europe for customized battery packs. Custom design, we have the capability inside our company to create our own packs, and also for fulfilling customer demands. Safety and compliance is utmost important for us. We always take all our considerations in terms of safety and compliance requests, and also regarding the regulations, etc. And then we have the supply chain. We have our own internal competences in supply chain, so we own our own supply chain. And this is important when we need to have full control over the manufacturing process and the production process. Local support, as I mentioned, we have offices in different European nations where we are able to provide you local support. Global account management. So as I mentioned, also we have offices in Hong Kong as well. So we are able to deliver projects globally, without any problems there. And as well as sustainability. This is a factor which we look into all the time for all our projects. And also we have our own vision for the company where we work towards sustainability, and we always strive towards a better, greener environment as well. Okay, so now just to, that was a very short introduction of our company and what we do. And now to the main aspect of this webinar. We'll be talking about battery basics initially, and then we'll be going deeper into how we can choose these batteries, or how to choose a particular battery for your application. So to begin with, let's go into history or the evolution of the battery cell. Battery as a term was coined in the 18th century, 1748, by the scientist Benjamin Franklin. Battery as a term was actually borrowed from, it's a military term. It was used to denote a group of cannons together, was called a battery. And now cannons are not used anymore, but batteries are. So, and then it has become much more important than anything else. And then we move on to the voltaic pile. This was created by Alessandro Volta in 1799, which was one of a landmark in the evolution of batteries. And then we have the Daniell cell in 1836. This was the first practical source of electricity in terms of a battery. And then in 1839, we have fuel cells. So we still think of fuel cells as a technology which could come, and we could help, have it. But it was actually invented back in the 19th century, where fuel cells are, of course, hydrogen and oxygen are mixed, are reacting, and then it will make electricity and water. And then we have lead acid as the first rechargeable battery technology, invented in 1859. And then we go on to more of the evolution. We have the Leclanche cell, which had the first dry electrolyte, which paved the way for dry cell batteries. We have the alkaline cell, which is very popular. It was invented around the turn of the century, in the 20th century, but it was not a consumer standard until 1959. So it was not used by consumers until then. Then we have primary lithium. So this is non-rechargeable lithium, which was created in 1912, but it again took a long time for it to be ready for the market in 1970s. The lithium rechargeable, very popular now, which was invented in 1985. Nickel metal hydride, NiMH here. These were also invented and available from 1989. And then to the future. What do we have in the future which could replace some of these technologies, or which we could use? So we'll be talking a lot more in this presentation about the 4 technologies mentioned here: alkaline, primary lithium, lithium rechargeable, and NiMH. But in the future, we might have different technologies which could replace them. We could have solid state electrolytes, lithium air batteries, lithium sulfur, or maybe even vanadium flow. These are technologies which are currently at research level, but they could easily be potentially be in the market and taken in a mass way soon enough. All right. Then we start with the basic types of batteries we have. And in the battery world, we classify them as primary batteries and secondary batteries. And primary is the non-rechargeable type. So that means the chemical reaction inside these batteries are irreversible. The main examples of these type are alkaline and lithium metal, and we will talk about this later on. Secondary batteries, these are rechargeable. That means the chemical reaction is reversible. And the examples of these are nickel metal hydride and lithium ion. To go a bit deeper into the inside of a battery, so we have the cathode as the electrode, the positive electrode, anode as the negative electrode, and then we have a separator which is dividing these two. And then we also have the electrolyte, which is the medium which provides the transport for the ions between the electrodes. So what we need to think here is that every battery will have these components, but then depending upon the material used and also the construction inside the battery, the properties will change. And this is where this is how there are several different battery types, but then we have to understand the properties better to choose the right battery for the application. So as I mentioned, there are different properties for the batteries, and these are some of them which you can see here, which I will mention here. These are not the exhaustive list of properties, but these are some of the major ones we look into. We have the nominal cell voltage. So this is the voltage of the battery, and this is dependent upon the technology inside. We have the energy by weight. And this is important when you want to consider how much energy we can store within a particular, within the particular weight or kilograms. So this is important when you have an application which needs to be lightweight or which is sensitive to weight. Energy by volume. So this is similar, but then it is dependent upon the size. So it is depending on the volume of the cell. So that is again something you have to consider when you have a constraint on the dimensions of your application or your product. Then we have overcharge tolerance. So this is when we need to understand what is the tolerance for overcharging the batteries. What would be the impact on its life if that happens, if overcharging happens. Then there is self-discharge. Now, this is a phenomenon where internal chemical reactions could reduce the capability of the battery to hold energy. So this is when we are. So this is a property which is pretty important when we need to store the battery and it's not connected to a circuit. And then we have internal resistance. So this is different components inside the battery can have its own resistance, and this might affect the discharge and charging performance. And then finally, we have cycle life, which is the how much cycles or how many charging and recharging cycles a battery can have before its end of life or before it cannot be used anymore. So moving on from some of those properties, here is a slide where you can see several different batteries, and these are all different technologies, but what you can see here is that they are all of the same size, and they are all AA size batteries, but we cannot choose a single one here, or we cannot replace one single one with the another for the same application. So the point here to note is that each application has its own technology, even if it has the same dimension for these technologies. Then we have, when we go deeper into the particular usage cases, so here we have a usage case for a drone application, which is an IoT application. So when we start communicating with a customer or a potential customer on how we can design the right battery for them, we first have what is called a CAP form, which is the customer application form. So here we gather all the requirements from the customer for their particular application. So, and this is a visual representation you can see here for this particular application. This chart we call a Pareto chart. And this is a very easy way to visualize what is the requirement or the wish from a particular customer in terms of their battery performance they need for their particular application. So you can see here, if you're in the middle is 0, and then it goes to 8. And then this is according to a scale of importance. So the lower the number, the lower the importance. So the customer wish here is that the battery should have high service life, for example, should have very good discharge performance, should be having great price, and energy should be pretty high with the capacity of it. So all of these are some of the wishes which we take and we can visualize here. And then in the next slide, we can see here what we do is that we try to pick the right technology of batteries to see whether they fit into these wishes. And then you can see here, if we go for there is no particular technology which can be perfect for a particular application. So if we take a particular battery type here, we can maybe match the price wish, we can maybe match the logistics of it, but maybe it may not be perfect in terms of service life, in terms of the energy capacity, in terms of the discharge performance. But we can find something which is pretty nearby, and then that is what we can propose. So the point here is that there is no magic battery technology which can perform in all of these criteria completely well. There would be some cases where you need to compromise on some of the properties. All right. So we reached the halfway point, so I will pass on the mic to my colleague Luca, and he will take the presentation from here on. Thanks.
So thank you, Sid. Thank you very much, Sid. And I'm take care of the part of the technology of the battery that we are selling through GPBM Industry, and we just simply divided by primary and secondary. That secondary means a rechargeable one. And we are starting with a few technology on the primary. The first one that we are looking at is probably one or the older that there are in the market, that is the Zinc Carbon. And what we would like to show in this presentation, but feel free to do any question, as mentioned at the early stage from Sid, through the chat, because here we are just having an overview of voltage, something related to the technology of each one that we are looking for. So on the primary, we are looking just 4 technologies. First one, as I said, Zinc Carbon, 1.5 volt, all the battery that are mainly done by 5 different sizes that are the what they call in the consumer the main one, that is torch or C, D, AA, AAA, and 9 volt. So simply quicker. Zinc Carbon, I say that is an old technology because it was probably one of the early that was born in the battery demand at the early of 70s, and where we were developing this market many years ago. That are, of course, due to the mandatory by the law, that's mercury free. That's not a question mark, it has to be. And it's mainly used for the remote controls and some clocks application. As I said, just to give to you an overview, we have done after a comparison in between Zinc Carbon and Alkaline, because Alkaline, that is the other technology that we are looking for, they have the same dimension of the cell. So next slide is really presenting the Alkaline products, where the main one, as I said before, the size is more or less the same. The voltage of the cell is the same as Zinc Carbon, 1.5. They're more or less copy-paste, as they mentioned. They have the application, it can be overlap with ZincCarbon, so it means clocks or remote control, but adding, thanks to the technology or the capacity that is a bit higher than the other one, and we look in the next slide with the Pareto chart, it is used also for application as is in toys, sensor, or even IoT application that is specific for some high discharge needs by the application themselves. So the next slide, there is the Pareto chart where it's clearly even using the same battery as mentioned before by Sid. So same dimension, AA, for example, when we are looking something related to the green line, it is the ZincCarbon, and the orange one, it is the Alkaline. So you see that even if it is same dimension, totally different characteristic by themselves. So there is something that is absolutely, I mean, not only in Italy, the attractiveness, it is the price, and ZincCarbon probably fitting the request about that, but probably not other requests that are more technical than only related to the single price. The real difference, as I already said before, it is the high discharge on the Alkaline compared with the ZincCarbon, but even the temperature, it is something that it's absolutely giving the gold medal to the Alkaline compared with the ZincCarbon. So at the end, what we are looking, it is less and less application on the ZincCarbon, but still available, and growing on the Alkaline in any case, even because the quantity in the long period and in the last period and in the future that we are seeing, it is a real growing on the Alkaline usage. So quantity on production, it's growing a lot, and the gap that there is in the price is really becoming lower and lower in between the two technologies. So that's just to give to you the overview of these two technologies that you have in ZincCarbon and Alkaline, but then we are going in deeply in something that it is lithium, that could be the dioxide manganese. That's one of the technology that we are looking, and the next one will be the Lithium Chloride. This one is 3 volt. That's the characteristic of tension of the technology in this case, and one of the characteristics, it is the energy density of the battery that is really high compared with the other one. Here that are available different sizes. If I have to take one of that is probably one of the main common for the application that we are looking in the market for different applications that you can find, it is the 123A that we are really looking in smart home, in sensor application, in the IoT. You have it even in security, in sensor more than security, but sensor, it's something that it can be drive or use the 123A. But then you have several others. Just to give to you an example, till a few years ago, 123A was one of the main battery that was on the photograph flash, that today is not anymore, thanks to the coming of the mobile that we use as a camera more than in the past. And it's really probably the main common battery that it is using in this technology. The real advantages here compared with the other technology that we showed before, it is high energy density, of course, but the other part is the temperature that you can have it, the operating one or the storage one, that absolutely much more important here than in the past. And the shelf life, because another thing that is differentiating the technology, it is the shelf life of the technology. As ZincCarbon, it is probably count in a month of shelf life. Alkaline is in year, a few years, and when you're going to the lithium, that it is manganese dioxide, is let me say 2-3 years more than the Alkaline. And then we are moving to the best one on the primary, that is the Lithium Chloride, best one, I mean, in the shelf life, but as Sid said, there is no real technology that it has to be totally correct for a specific application, because it depends on several other options and opportunities and requests from this application that could be even connected to the electronics. So that one on shelf life is the longer we have on the primary, that is around 8 years or even more. And the voltage, it is 3.6. That's a characteristic of this technology. Long shelf life, as I mentioned before, And a characteristic or the application that we can have it is metering, it is trackers, IoT, and again security alarm and few others application on the IoT as we mentioned as a sensor too, or being a power for the home security alarm. This technology it has to be viewed in two different way. It depends on the cell construction, and the cell construction it has to be divided by bobbin one and the spiral that you can clearly see on the next slide related to that. The bobbin one, it is the that's the left one. It is the internal construction that is a bit different in between the two cells, having the same size, so same dimension. But you can see that due to this way of construction, you have different characteristics on the battery cell. That it means that the bobbin time has the high energy. Usually you find, if I'm taking the lithium chloride, that is a characteristic of, you probably have something around 17 amps or 19 amps available as energy. But on the other side, this one, the capacity, high energy, it's extremely positive, but the continuous current, it has to be much more lower, it's maximum 250 milliamps. On the other side, the spiral, I have a lower capacity on the cell, so it means that it's probably around 13-14 amps as capacity on the D cell, but you have a continuous current that you can get from the cell, it's around 2 amps. So it's again same size, same battery, same cell, different construction, different characteristics. So even if that are lithium chloride both, it's totally different, the battery or the usage that you can apply on the application. So that's the part of this presentation related to the primary. Then I'm going to the enthusiastic secondary, because why enthusiastic? Because I really like the fact that looking the secondary or the rechargeable, you can really build up from scratch, from zero, a battery. So you can do a battery pack, you can edit some electronics, you can edit some controller, you can edit some controller on temperature. So the primary is that one. Is the mechanical is that one. The rechargeable, you have to be really starting from let me say ground zero to arrive to the definition. And you see then what we can do on even through the EXO, that is a sister company that we have within our group for doing the packaging or for doing the building pack or any other electronics. But then we see over there. So on the secondary, we really touch what we have in our pipeline. Of course, nickel metal hydride. A lot of people or a lot of people are looking that is an old technology, but I'm really enthusiastic on that because this old technology is stable. There are a lot of knowledge about from our side, but even from the customer side, several sizes that we can choose which dimension it is needed. Thanks to the fact that the nominal voltage, it is 1.2, you can build pack for 1, 2, 3, 4, 5, or even arriving to the 20 pack, 20 cell for doing a pack, 24 volt. So it's really flexible, available in the market for a long time. So stable, safety, and no real issue on transportation. So that's why I'm really looking this technology as probably one of the best we have, and the knowledge that we spend even internally, it's pretty long, as we have a long relationship with the supplier of that is GP in this case for the nickel metal hydride. In this case, as it is a sort of custom product, saying which is the application, that are several. So we can say that the application, it is a remote control or something like that. It is also remote control, but you have to apply this kind of battery even on the medical application, even in remote control. It is another one, but you have the IoT application, absolutely. You have the automotive one, that it could be starting from the siren of the automotive of the car, arriving to totally different looking how it is the use for the Tesla products, so e-car. So that's what I mean in really flexibility and customized products. So this one is nickel metal. Just a quick overview because we don't have enough time for. We are going to the again rechargeable, again secondary, but miniature batteries. That is a range of voltage is pretty wide. Again, it's mainly related to the wearable application because it's really small. It has to be in coin cell or pin or even cylindrical one. It depends on needs, but it's mainly, I would like say, application. It is the earbuds. So internal there is the coin cell of the there or small charging cases. We are doing some study even in the hearing aid. That's the part that we can also looking for this kind of application. Another one that I'm thinking, it was the TPMS, that was for checking the pneus control on the gas inside. So that's just to view that the technology is growing and we are following this part of the technology and we are part of this evolution of. Then I'm going to the, again, secondary battery, but the lithium ion, it is the, let me say, the common one. I would like to say that the lithium is part of the, probably 80% of the market. It is connected to the 1865 cell. That is the common one, and it is a standard cell. Application is pretty wider, starting from Tesla, that is probably the main common, arriving to the charger for the computer, the PC, or arriving to others that is much more simple, that it could be even airbag for moto. So we have really several different applications. We are just showing as a picture a single cell, but of course, probably nobody uses only the single cell, but they're doing a pack. We could be connected some control on the battery pack, that is the BMS, or some connector or some PTC or NTC or any other control on this battery that can be, if it is not used in the right way, can become dangerous, and it can be some difficulties on the transportation, as lithium now is under control of all the forwarder due to the fact that in the past there were some problem on the transportation side, as the Samsung PC that were booming, and it creates some issue. But again, we are safe and we would like to work with, and for all these kind of cell, we have the UL that it can permit even the transportation by air. The last technology that we would like to look into the rechargeable, it is the polymer or pouch or whatever you want to call it, but it's the real things in comparison with the other. It is that they're really flexible, smaller, thin, flexibility absolutely even in the capacity. So it is something that you have to cut in the polymer, and it's really interesting and capable to reach any kind of request of the customer for doing any kind of product. Application is, I would like to say, all the things that are needed energy, but that are smaller and thin. So everything is going in. It's not a round cell. It is really a pouch, as we call it, and it is really simple for using in that application that are really thin, as smartwatches or a smartphone or anything it is needed in that sense. So the other few slides that we really saw, it is just to give to you an overview about the application that we have in smart home. And the next slide, it is the connected to this smart home. We just analyze that in a home you have so many different machines that needed the battery. Before we were going even in deeply, but what we are seeing here, that we probably didn't get all the application within the home that we have. And the real thing is that primary and secondary in many of these applications can be fitting in both application. If I really look door window sensor for opening the door, it could be that you are using rechargeable or for doing the backup off, but then it can be used even the primary. So it's really to show that you have many applications on the smart home, Each one has its own battery. Mainly probably can be primary for the easy usage and about that, but on the rechargeable you can probably cover 95% of the application that you see here in any case. So really, battery is a part of our life. You can see here in this picture, and we didn't exaggerate on the application, because then when I see this picture, I try to apply at home, at my home, and I would like to say that I'm not far from that. So it's really something that you have to look into, and primary or rechargeable are both fitting the request that it can come from this application. Smart home, it has to be probably IoT one. Of course, we have some experience in some specific application. Some other we are not so present, but absolutely it is something that we have to look into and going in deeply, because each one has its own needs, and each one can be fitting primary or secondary battery. That was the part of, and the last slide that I would like to say, it's the part that I say the last, but it's probably the first one, because we are working, as I said, fixed from 86 in the market. We are working with partners that are safe and reliable, and that's what it is, what we would like to do, even for being a partnership with any kind of customer or partner for the next future. That it is because safety is a part that we would like to be a part of. We are doing a lot of effort even on this part with the supplier partner or even ourselves for giving certification, following the regulation. And believe me that in the last few years we have several changements on the regulation and the transportation within Europe or even worldwide, and we are trying to follow everything that it has to be, that to give to the partner customer, even us and the supplier, the safe and reliable products for being a partner and not some opportunistic business that we would like to do. So that's really a part that we would like to underline, and that's a part that we are part of this process, and we are looking with the division internally on the quality-wise for this needs that is requested by selling a battery. We want to be serious and not, as I said before, an opportunistic business of the there. So that's the part of safety and quality. I really feel that the next slide would be the presentation of the next webinar, I feel. Yeah, the idea it was to start with this webinar that is a pretty wider on the products or technology, and we would like to organize another seminar that will be only focused on the primary solution. Solution, it means a bit wider than battery, so it's something really applicable on that. Again, the idea it is to do in the next period, doing a seminar once every month and a half. And the idea it is really to do this primary solution on the 9th of June, maintaining the same time frame that we have to do today. That's all from my side, but feel free now. I don't know if there is some question that you have already written over there that I don't know. I don't see anything about. It could be Martina El Paz in some way on that.
Yeah, Martina here. I don't see any questions at the moment. I know that there's a tiny delay, so we will wait just a minute or so for to see if any questions land in our little chat. Anas, do you want to answer the questions when there comes any?
Of course, yeah, of course.
Yeah. Okay. Maybe you can introduce yourself in the meanwhile, Anas.
Yes. So my name is Anas. I am the sales manager of France, and I have technical background. So please feel free to ask your questions in the chat area, and I will do my best to provide you all the answers.
Okay, we have a question here from Anonymous. asking which chemistry has the widest temperature range?
Actually, it depends if it's primary or rechargeable, and also on the temperature range that you are referring to, and on the other characteristics of the of your application. I would say that the best one could be nickel metal hydride if you are referring to rechargeable application. If it's primary application, then maybe lithium chloride. If you have moderate current. But again, as Sid said in the beginning, it will depend on other parameters like the discharge profile and also the service life and several type of questions. So please feel free to contact us, and we will send you our application form, and then we can discuss about the details of your project and provide you the best option or best solution for your project.
Okay, then we have another question from Mauro. In this period, some critical shortage about components and increase in prices. Which is the situation for batteries in general?
Yeah, we see that due to some issues with plastic manufacturers and for that are used in the connectors, we see an increase of lead time for the connectors. It's the same for silicium manufacturers and integrated circuits manufacturers. There is a huge increase, which is affecting mainly lithium ion batteries because they are using a BMS or PCM with the electronic components. So there is a small increase in terms of lead time. And for the price increase, we can see that during the last months, the price of raw material is increasing. So there is a small impact on the price of the batteries. But yeah, I think the situation, you know, that we are using raw material to produce the batteries. So when the price of raw material increases, it's affecting also the batteries. But it works also on the other way. When it decreases, the price of the batteries will decrease as well.
Good. Now another question showed up. It's which technologies allow for a longer service life for secondary batteries?
I would say nickel metal hydride. I would say nickel metal hydride for sure. But it's also again depending on the dimensions of the pack, the requirements in terms of weight, etc. So again, it's the overall requirements of the project. But if you are only considering service life, I would say nickel metal hydride.
Another question from Mauro here. What about the case format? Is the standard cylindrical 18650 will be still maintained in the future, or new formats like the 21700 will win the application market? Which one will be the winner?
So I would say that 18650 cells are now very famous and known in the market because they were initially used in the automotive market. And so this is why we use them a lot. So what will be the trend in the future? It's difficult to predict because the market of lithium ion is mainly driven by automotive projects and applications. Maybe it's possible it could be this size or maybe another one, but for sure, for now, what we can see now in the market is that the 18650 cells are the number one size of cells used for lithium ion applications after lithium polymer.
All right, two more questions. First one, which are the most important properties for a wireless solution?
So yeah, I think that for wireless solutions and maybe IoT applications, it could be a topic for a new webinar. I think that it will take over half an hour to talk about all the possible options for wireless solutions. What we can see in the market is that it's mainly, at the beginning, it was mainly lithium chloride because it was used in low energy networks like Sigfox or LoRa. Now we see that more and more products are offering several communication networks like Bluetooth, low energy, LoRa, Sigfox, and LTE for mobile, for IoT and other networks. And which means that these applications require more and more or higher discharge currents and more energy. So we see a trend where the customers are changing from lithium chloride to lithium CR or lithium manganese dioxide. For rechargeable applications, I would say it's lithium polymer, number one. But since few months or years, I would say, especially with the wireless headsets, the AirPods, and the customers are requesting more and more miniature cells for wireless devices like AirPods or headsets. So lithium polymer is possible. It's very thin. It's easy to install in, for example, a watch or a mobile phone. But for portable devices that are requiring more safety features and extra redundancy, we would recommend using a miniature or coin cell, the ones that Luca has presented in the lithium ion section. Will there be a lithium shortage due to EV? Shortage, I don't think so, because the production lines that are dedicated to EV are mainly producing only EV batteries. For industrial applications, it's not the same. It's not the same market, and usually it's not the same factories. So yeah, for sure there is a huge need for lithium ion batteries in the EV market, but it will not affect the other applications for consumer or for industry. And please feel free if to send us your requirements, and we will evaluate the project, your requirements, and recommend which technology or which type of lithium chemistry will be better for your projects and for your application.
We have a few more minutes, but maybe we can show the final slide, which is the contact details. And we can Yeah, so feel free to contact us for any of your queries. We'll be happy to help you. And yeah, we have a 5 more minutes open for questions, and we can answer you. It seems like we don't have any new questions. So so let's wrap up, I guess. So thank you very much for being part of the webinar. As I mentioned, and as my colleagues also mentioned, feel free to contact us for any kind of queries. We'll be happy to help you out in your project. And also, you know, follow us on our LinkedIn page. Then you will get more information about this webinar and also upcoming webinars. And yeah, do attend, and please let us know your comments as well later on. Thank you. Thank you for attending, and have a nice evening or morning wherever you are. All right, bye-bye.
Thank you. Goodbye.
Bye.
Thank you. Bye.